Hey guys, in this video we'll be going over how you can control your robot with this RC controller. We'll be covering how the controller works and how it sends signals to the RC receiver, and then we'll be going over a simple program that takes the value sent from our RC controller and uses that to control a robot. So let's start by first going over how our RC controller works. And to do that, we're going to be using this setup here, where we have our RC receiver hooked up to a power supply and an oscilloscope. This oscilloscope will allow us to read the signals that the RC controller sends to the receiver. Now, let's take a look at our RC controller. To turn it on, simply press and hold this button in the middle here. Okay, now that it's on, let's take a look at the controls. This controller specifically has a total of 6 controls that we can use. We have these 4 buttons here, and we have the horizontal direction on our joystick and the vertical direction on our joystick. Now, this is important as each of these 6 controls corresponds to one of 6 channels that it sends a signal to. So currently, if I turn this on, the oscilloscope is hooked up to channel 1, which corresponds to the horizontal direction on our RC controller. And now we can see, if I move the joystick to the right, the signal changes. Specifically, the duty cycle increases. And as I move it to the left, the duty cycle decreases. So we can see, by modifying the horizontal direction, it changes the signal that we send to the RC receiver. And we note that if I modify any of the other controls, it doesn't change the signal being sent to that channel. Now, let's read channel 2 instead. Channel 2 is connected with the vertical direction of the joystick. So this time, if I move the joystick up, we lengthen the signal. And if I move the joystick down, we shorten the signal. Now let's move it to channel 3. This corresponds with this top button here. And the buttons work slightly differently. Currently, the signal is a specific length, but if we press the button, it changes the length of the signal. If we press it again, it moves the signal back to the same length it originally was. And once again, it's just for that specific button. The other buttons won't change the signal being sent to channel 3. Now, with the signals being sent to the receiver, we can take the information that we get from that to determine how we are modifying the controls on the RC controller. And thus, we can use that to do something like, say for example, move a robot. Okay, so now we'll be going over this simple program. This program should allow us to control the movement of the stacker using the joystick on our RC controller. So let's go through it, and just keep in mind we won't be going over the initialization of the motors, as that's something we already covered in a previous video. So to start off, we declare these 2 variables, horizontal pulse and vertical pulse, and they'll be used later for storing the values that we read from our 2 channels that correspond with the directions of the joystick. Next, we define the 2 pins from our microcontroller that we want to read from that will ultimately be connected to the two channels on our receiver. Next, in setup, those two pins that we defined earlier, we're just setting them here to be used for reading input from them. And then we also have this break function, which we didn't cover earlier. This just sets the motor speed to be 0. Now, this is the bulk of our program, and it's in this main loop here. To start off, we use this pulse in function, and this will allow us to take input from our two pins that we mentioned earlier. And of course, as mentioned earlier, these are the two pins that are connected to the two channels that we're reading from on our receiver. And it takes the input from that and stores it in these two variables, horizontal pulse and vertical pulse. These are the ones we declared earlier up here. Next, we have this if statement. And essentially what this if statement is for is it's checking if these two values that we read are within the proper range. So with this specific RC controller for the joystick, it should be sending values that are between 999 and 2000. Any value that's not between that is junk value and we should ignore it. Hence why we have this if statement. However, if the value is good, then we can move on. So next, here we have these two variables which we declare, speed and direction. And to get the value for that, we use this map function. And what this map function does is, given a value and a specific range, it will give the corresponding value for a second range. So, for example, we have speed, this variable speed here, and we take our vertical pulse value, and we know it should be between 999 and 2000. That's the bottom and top of our range. And we want to get the corresponding value for that between -255 and 255. So for example, if our joystick was left unbothered and was in the middle, it should return roughly the middle of this range, which is around 1500. And that would result in our map function returning the middle of the second range, -255 to 255, which of course would be 0. And we do this because, as we talked about in a previous video, the motor's drive function only takes values between -255 to 255. So essentially, we first read our data from the receiver, and then we interpret it in a way that we can use for our motors. Now over here, to get the exact speed that we want to set our motors to be, we do the small calculation. We take our speed value, which remember is from the vertical pulse, which takes values from the vertical direction of our remote control, and the horizontal pulse, which corresponds to the horizontal direction on our remote control. So speed should be controlling the forward and backward movement of the bot, and direction should be controlling how the bot moves in its left and right orientation. So we do this little calculation here, one for the left motor and one for the right motor. And then we also use this constrain function. And what this does is it makes sure that our value that we get from this calculation will still fall in this range, -255 to 255, the range that the drive function uses. If the value of the calculation happens to be greater, then it will default to the maximum of the range, 255. And if it's lower, then it will default to -255. So ultimately, now that we have the two values for these variables, left speed and right speed, we can set the speed of each motor to be these two values. So ultimately, what we're doing is we're reading the values that the RC controller sends to the receiver, which sends to the microcontroller. Then we're taking those values and we're interpreting it in a way that we can use here for our motors. And then of course, we're ultimately setting the according speed for our motors. So this concludes the presentation of this program. Okay, now that we covered how the program works, we can see it in action right here. We can see I have a stacker, I have the RC receiver, and the controller. Now, of course, for this to actually work, we need to connect our RC receiver to the microcontroller. So to do that, we're going to use this adapter right here. As you can see, I already connected the RC receiver to the adapter, and you guys should connect it like so. Then we can connect the adapter to this set of yellow pins on the stacker and make sure to connect it with this orientation. Now here on screen we have a diagram which shows what channels are connected to what pins on our microcontroller. As you can see, channel 1 is connected to pin A0, channel 2 is connected to pin A1, which of course these are the two pins we had in our program, and we also have the other channels. For example, channel 3 is connected to pin A2. Now, we can turn our stacker on, and we can see that the RC receiver is flashing green. This means that it's looking for its controller to pair with, and of course means it's also powered. So we can turn on the controller, and now we see we have a solid green light. This means that it's on and paired. So now let's see if it works. If I move the joystick forward, the robot moves forward. If I move it backwards, it moves backwards. If I move it to the left, the robot spins to the left. If I move it to the right, the robot spins to the right. And of course, I could move it around however I wanted to. So that concludes our video on controlling the stacker with an RC controller. Thank you for watching.